Okay, hi Year 12, here is integration section. So I'm doing this. You may have wondered why I always start with me before I go onto the Word document. It doesn't seem to record if I do it the other way around. So it's a bit unfortunate that you have to see half my face before we start every video, but I'm sure I'll figure it out differently at some time. Right, okay, so integration. So there's an awful lot of differentiation on this test. Integration you haven't done so much of, but we're just going to be concentrating on indefinite integration. So that is where we don't have limits. So we have got a series of 4 or so questions to integrate. And this first one, it isn't as simple as it could be. I'm not sure whether that was an error of mine to put them in this order. A little bit like differentiation, we cannot integrate fractions. Okay, so what we have to try and do is to see if there's a way of rewriting the expression to make it look nicer. 2 ways that you could do it. Because I've just got a single term on the denominator, I could write that one fraction as 2 individual terms. And then I can use my rules of indices and say, okay, well, x to the power 4 over x squared, that's x squared. So that first term is 6x squared. And then here, well, I can't integrate that where it is on the denominator, so I need to rewrite it as a negative power. What some of you may prefer to do is to write it as x to the power of minus 2 multiplied by 6x to the power of 4 plus 4 dx. And then, of course, it turns into multiplying x to the negative 2 multiplied by 6x to the 4 is 6x squared, and then x to the negative 2 times by 4 is 4x to the minus 2. So we get to exactly the same endpoint. It's up to you which you prefer. Now we've done that, the actual integration should be fine. When I integrate, I increase the power, I divide by the new power. So what I'm going to do is I'll just write that 6 at the start. I know I'm going to have an x cubed. I'm increasing that power by 1, dividing by that new power. I think probably what most of you are doing now, using fractions than having a divided by 3 underneath. It's a little bit neater, and as well it makes it easy to simplify afterwards. That second term, there's a negative. So I'm just going to take a little bit more care with that. Write the 4 at the start. Okay, I've got my x. I'm adding 1 onto negative 2. I'm getting negative 1, and then I'm dividing by negative 1. Dividing by negative 1 is the same as multiplying by negative 1. So I can write it like that and we'll just switch the sign. Next bit, really, really important. Plus c. If you don't write plus c, you will lose a mark. And it's such an easy thing to do. You know, why would you not put your plus c? You have to put the plus c there because there's a whole bunch of functions that we would differentiate to take us back. C could be anything. When we differentiate it, it will vanish, leading to this same original function. So now just simplifying, 6 times the third is 2. So 2x cubed. And then here I've got 4 times negative 1, so that's minus 4x to negative 1 plus c. And I don't know, I think you'd get your full marks, but I don't like seeing negative indices, so I'm just going to rewrite it like that. Plus c still there, however, must have the plus c. Second question. Those brackets make it a little bit awkward, but sometimes exam questions do this. Just to emphasize the fact that you are indeed differentiating both of those terms, they've just put it in a bracket. But, you know, think of it, it's just, okay, I'm just integrating those 2 things with respect to x. So when I'm integrating, integrate 3, it's just 3x. You can think of it, if you like, as integrate x to the power 0, add 1 to the power, divide by 1, but we know it's just going to be an x. Okay, I haven't written that as 4x to the half. Now that I've done that, I'm going to write that. I'm going to write the negative 4 down, and then I'm going to think about integrating the x to the half. add 1 to the power, dividing by the new power, dividing by 3 over 2 is just the same as multiplying by 2/3. Plus I've got my constant, and then tidying that up, 4 times by 2/3, 8/3 x to the power of 3 over 2 plus c. There's no value really in writing that as square root of x all cubed, because well, it just looks really really quite messy. So there's no benefit for that, so I'm just going to leave it as it is. Okay, so next up, there we go. Again, we've got those brackets, but it just means, you know, integrate both those bits. I don't think there's anything there I need to rewrite, but I am just looking ahead to there. I've got fractions, I've got negatives, so there are lots of places to go wrong. So just make sure you're careful. Integrating the 4x, however, right, I can do that. 4x squared over 2. So 4 times by x squared over 2, and actually there I have written a division, haven't I, rather than the fraction. Right here, minus a half times by, so I'm going to write my x if you need to. All right, minus 5 over 2 plus 1, that's minus 3 over 2. So I'm going to have minus 3 over 2, and then I need to divide by minus 3 over 2, which is the same as multiplying by negative 2/3. I just had a panic. I didn't put plus c on the previous one. I am going to put it on this one also. So 4 over 2 is 2x squared, and now here that half and that 2 cancel, and I've got a negative and another negative, so that is going to be plus 1/3 x to the minus 3 over 2 plus c, and that's it. Particularly because the question gave me negative indices and powers of a half. I don't think there's any value at all in rewriting that in a different form, so I'm going to stick with that. Okay, right, next up then. Here, I think we differentiated something similar earlier. The same thing applies. We cannot integrate products, so we have to expand the brackets. So if I expand those brackets, I'll have 2x times by x squared. So that's 2x cubed. I've got x squared times by negative 3. I've got, no, I've done that one. I've got 2 times by 2x, that's 4x, and then I've got 2 times by negative 3, so negative 6. So I need to differentiate, no, integrate that. So write the 2 down, times by x to the power of 4 over 4, write the 3 down, okay, increase the power, so times by x cubed over 3, write the 4 down, times by x squared over 2. And I need to add on an x at the end there, plus my constant, mark lost if you don't do that. And then 2 over 4 is a half, so a half x to the 4. Those 3's cancel, I've got 3 times a third, so it's minus x cubed. Then I've got 4 over 2, so that makes me 2x squared minus 6x plus c. Okay, now we have got, I think it's the last one of the integrations. Similar to the first one, in that we have got a fraction, but it just looks more horrible. But don't panic. I'm going to use exactly the same technique. I'm going to write that as 2x over 3 root x, and then minus 1 over 3 root x dx. You may prefer to have that as a power of a half. And now I think I'm in a position where I can rewrite that. This of course, 2 over 3, 2/3. So just write that as a separate fraction. And then I've got x to the power of 1 over x to the power of a half. I'm dividing, so I subtract the indices. So that's 2/3 x to the power of a half. Here, I've got 1 over 3, so I can write that as a third. And then I haven't got any x on the top, so I just think about that power of x on the denominator, and it's negative a half. Now I'm in a position where I can integrate. I'm going to write the 2/3 down. X, add 1 to the power, 3 over 2. If I divide by 3 over 2, that is multiplying by 2/3. And then minus 1/3 times by x, add 1 to the power, it's going to be plus a half, and divided by a half is the same as multiplying by 2, plus my constant. Tidying up, I've got 4/9 x to the 3 over 2 minus 2/3 x to the half plus c. Okay, there we go. Hopefully that was a little bit of a shorter video, and circles next. Stop recording.